All right, here is the last example we're going to do for 9.4, partial fraction decomposition. And this is talking about what happens when we have a quadratic in the denominator that doesn't factor. So we end up with a factor that is a quadratic, essentially. So when we're setting up our new fractions, when we have something in the denominator that's not linear, then we need to set up the numerator in such a way that is 1 degree less. So if this had been cubic, I would have needed to set up a quadratic in the numerator. So it has to be 1 degree less. Essentially, you could think of it as when we're doing polynomial long division. This would be the highest degree form that the remainder could take, right? My remainder, for if I'm dividing by this, could be linear, right? So this is the highest degree that the remainder could take, or 1 degree less than the denominator. So it's going to be 1 degree less than the denominator. So again, it's possible that b could be 0. We don't know, but we need to put it there in case it's not, right? We're not guaranteed that b is going to be 0, but it could be. Once we get this set up, though, the process is the same as it has been the whole time, and as it has been in the last two examples. So once we have this set up, we can just multiply the whole thing by our original denominator. So we're going to multiply. We multiply this side, as always. They will both cancel, and we end up with just the numerator. We multiply this by the original denominator, then the x plus 3 cancels. We end up with a times our quadratic. And then for this one, we multiply, the quadratics are going to cancel. We end up with bx plus c times x plus 3. So here we're going to have to FOIL, and then as usual, we're going to have to distribute here. So that's our next step. So that's what we're going to do. So this would equal ax squared plus ax plus 2a plus bx squared plus 3bx. I'm running out of room. Plus 3c. Why did I do it in that order? That's weird. Okay. Plus cx. Sorry. I did this one and then this one. Oh well, same result. And then just like we've been doing in the other examples, we're going to put the things with the squareds together, the things with the x's together, and then the things that don't have any x's will go together. So we have, I'm going to write that up here. We have ax squared plus bx squared. And then we have plus ax plus 3bx plus cx. And then we have plus 2a and plus 3c. So then in this first set, we're going to factor out an x squared and then factor out an x, and then those will just be the same. So we end up with a plus b x squared plus a plus 3b plus c x plus 2a plus 3c. And then just like we've been doing, we're going to compare that with our coefficients in our numerator, our original numerator. So the coefficient of the x squared has to match the coefficients of the x squared. I'm going to erase this so that I can write over here. So that's a plus b equals 8, right? And then a plus 3b plus c equals 12. And 2a plus 3c equals negative 20. Okay, so now we have 3 equations and 3 unknowns. This equation has a and b, and this equation has a and c, so we can't go straight to 2 equations, 2 unknowns. We need to do some finagling to get there. So let's go ahead and do that. So what I'm going to do is I'm going to add these two, getting rid of the c. So I'm going to multiply this one by negative 3, and then we're going to get rid of the c's, and then I'll have another equation that just has a and b in it. So multiplying this one by negative 3, I get negative 3a minus 9b minus 3c equals negative 36. Sorry, that's over the words. It's negative 36. And then adding to that 2a plus 3c equals negative 20. So we end up with negative a minus 9b equals negative 56. And then I'm going to add to that this equation. So now we have 2 equations with 2 unknowns, right? So I can just add this equation. So I have a plus b equals 8. And so the a's are going to cancel. So I get negative 8, b equals negative 48. And then I can just solve for b at that point. So if I divide both sides by negative 8, I'm going to get that b equals 6. So b equals 6, and then I can just start back substituting. So I know a plus b equals 8. So if b equals 6, a has to equal 2. And then I can substitute those two back into, or I could just plug the a into this one, probably be the fastest. I can plug a into this one. So I get 2 times 2 is 4 plus 3c equals negative 20. So 3c equals negative 24. And then I can just divide both sides by 3. And I get that c equals negative 8. So yeah. So that's the basic strategy here. Sorry, it kind of is a mess. So, and then once we have all of our solutions, right, all we need to do is write them in our fraction format for our final answer. So I'm just going to make myself room so that I can actually do that. So A was 2, so we have 2 over x plus 3 plus bx plus c, so 6x minus 8 over x squared plus x plus 2. So this would be my final answer. The book actually does this in a different way, and if you want to look at that, go ahead. It doesn't always work, but it sometimes does. So if you're interested in looking in that other way, that's completely fine. But I didn't show it to you because I prefer to show you things that will always work, or at least usually work. And so to me, I feel like it's easier to have one strategy that always works instead of trying to show you a bunch of different strategies that may or may not work. So that's up to you. Yeah, so this is 9.4. Let me know if you have any questions, and I will see you guys soon.